We'll now continue our discussion on confidence intervals. So let's take one more look at the formula that we'll be using as we go through this section. Our next example says, for a group of 20 students, and again I'm going to write as we go, so as a group of 20 students, that would be our sample size. Taking a final exam, the mean heart rate was 96 beats per minute. So we know that for our 20 students, the mean of that sample was 96. And the standard deviation was 5. Now, I want to be careful here. Remember that we need to be sure that we have the standard deviation of the population. Okay, so remember that in our formula requires that we have that symbol, which stands for the standard deviation of the population. So, looking at this example, I don't think that's what we have. Because in this sentence, where it's talking about selecting a group of 20 students, and we know that that 20 students represents our sample. They have calculated the mean heart rate for those 20 students, and they've also calculated the standard deviation for those 20 students. So that standard deviation that they're giving me is the standard deviation of the sample. So we'll use the S symbol for that. And then the problem continues and says, find the 90% confidence interval for the true mean. Okay, so what is going to happen here is that I'm going to take my formula and I'm going to make a couple of changes to the formula based on the information that I'm given. So the first change that I'm going to make is I'm going to substitute in, instead of the standard deviation of the population, I'm going to substitute in the standard deviation of the sample. Now, I can do that as long as I also make a change here. So I am going to change this Z alpha over 2 to a T alpha over 2. Okay, so let me kind of clarify this just for a second. So in our formula, if we have the standard deviation of the population given, then we're also going to be using a Z-score. Those two go together. But if we need to use the standard deviation of the sample, we're going to use a T-score, and those two go together. And you want to link that together in your head. You can't use the standard deviation of the sample and a Z. You have to use them paired up the way that we've got them written there. Now, the T-score simply comes from a different table. So you should have back in Georgia View a copy of the table posted. The table that we're going to be using is called Table F, and a portion of it looks like what you see here on the screen. Okay, so let me give you a little bit of advice about using this. We are going to be looking specifically at the first row, the first row of this table where it says confidence intervals, and looking for the percentage given to us in the problem. And then this DF is your sample size minus 1. Okay, so you're always going to take your sample size, subtract 1, and that's going to be your DF. So let me go back to my problem just for a second. All right, so we have the 90% confidence interval. So that's going to tell me that I am using this column because that is the column for 90% on the confidence interval row. And then I know that my sample size is 20. So when I go back to my table, I'm going to use the row that has 19 in it. Remember, sample size minus 1. All right, so I'm going to come across here, and I'm going to come down here. And so my t-value is going to be 1.729. All right, so I'm going to come back over here, and let's write that down so we don't forget it. 1.729. And then we are ready to plug in our values into our formula. All right, so the x bar, I'm going to put a 96. My t-value, 1.729. My standard deviation of the sample is 5. My sample size is 20. Same thing on the other side, but with a plus. And then again, we're going to go to our calculator and type that in. We're typing in the left-hand side separate from the right-hand side. And we're rounding our final answers to 2 decimal places. So on the left, we're going to have 94.07. And on the right, 97.93. And so again, remember that the mean of your sample is 96. We're using that mean, which is for the 20 students, to predict what would happen for all students. And so the mean heart rate for all students should fall somewhere in between these two values. And we have a 90% confidence that that happens.